Okay, so today we're going to really get into a topic that I think is pretty fundamental for anybody who is really thinking seriously about software architecture,
Mm,
especially if you are looking to, move into a senior engineer role or if you're going through technical interviews.
yeah.
And that is the monolithic architecture.
Hmm.
Now, I know that, monolith can sound a little bit like, a legacy term or something,
Oh,
that people are trying to get away from.
yeah.
But we're not here to just, dismiss it. We want to actually like really understand what it is
Hmm.
in its different forms so that you can actually speak about it intelligently when you're in an interview setting,
For sure. Yeah.
um, and think about it with more nuance than just, you know, monolith bad, microservices good.
Absolutely. Yeah. And I think, especially when you're preparing for those senior roles,
Yeah.
the ability to really like dissect different architectural styles
Right.
is really key. It's not just about knowing the buzzwords, but it's about understanding the trade-offs. Right. And the monolith is no different. There's variations of it.
Right.
And being able to speak to those different variations will really kind of elevate your understanding
Exactly.
in any technical discussion.
Okay. So let's get down to brass tacks here.
Sure.
So when we say monolith, what is the like fundamental characteristic that we're really talking about here?
So at its heart, a monolith is a unit of deployment.
Okay.
And so basically everything that makes up that application has to be released together.
Hmm.
If you make a change to one part, you're deploying the whole package.
Gotcha.
Now, within that fundamental definition, there's actually a few common ways
Okay.
that these systems are structured.
Okay, cool. So let's start with the one that I think most of us probably have in our minds when we think of a monolith,
Mm-hmm.
which is the single process monolith.
Right.
So what does that look like, on a day-to-day basis?
So a single process monolith is pretty straightforward.
Okay.
Basically, all of your application code runs as one operating system process. You might have multiple copies of this running, to handle more users or to ensure that if one copy fails, the other one can keep going.
Sure.
But logically, it's one big block of code all working together.
Mm.
One interesting thing to point out here, though, is that even this seemingly simple setup
Yeah.
almost always interacts with other systems like databases, sending data to maybe a mobile app or a web browser.
Right.
And so in practice, even a single process monolith often operates as like a basic distributed system.
Right. It's never really just a completely self-contained island.
Totally.
It's always got these connections out to, different services.
Mm-hmm.
So you mentioned that this can actually be a good way to start,
Totally.
especially for certain kinds of organizations.
Yeah, absolutely. I think especially, if you think about like the early stages of a company, the creator of Ruby on Rails, David Heinemeier Hansson,
Right.
often makes this argument pretty forcefully
Hmm.
that this kind of architecture is often the ideal starting point,
Mm.
especially for smaller teams. When you're small, that sheer simplicity of deploying one thing
Right.
can give you a huge advantage in terms of speed and not having to worry about a lot of operational complexity.
Right.
And it's also important to note that, this isn't necessarily a trap. You can evolve this as the company and the system grows.
Right. Which leads us to our next type of monolith, which is the modular monolith.
Yes.
And so this sounds like it's a little bit more sophisticated, but it's still within that single deployment package.
Mm-hmm.
So
Yeah.
how does this work?
So imagine a single process,
Okay.
but internally it's organized into independent modules.
Okay.
The key here is that different teams can work on these modules,
Mm-hmm.
maybe even test them separately.
Okay.
But at the end of the day, they're all compiled and shipped together as one unit.
Mm-hmm.
So think of it like a really well-organized application with clear boundaries between, different functional areas.
Right. So you get some of the benefits of separating concerns.
Mm-hmm. Yeah.
Different teams can focus on their own domain.
Exactly.
But you don't have to deal with some of the deployment headaches
Totally.
that come with fully distributed systems.
Yeah, precisely.
Right.
And if those module boundaries are well-defined and respected,
Mm-hmm.
you can achieve a significant amount of parallel development,
Right.
which can be a real boost as your team expands.
Yeah.
And when you compare it to something like microservices, the operational overhead around deployment is still much lower.
Mm-hmm.
A great example of this is a company called Shopify.
Okay.
They've used a modular monolith to manage, significant scale without going fully distributed.
Shopify. That's a really concrete example.
Yeah.
You touched on one aspect of this that I think is really tricky, which is the database.
Mm-hmm.
And the database often feels like the most tightly coupled part
Absolutely.
of any system. So.
Yeah, so typically, even in a modular monolith, you often have like a single shared database.
Mm-hmm.
And this can become a real sticking point down the road if you decide you want to break things apart into separate services. Because the way the data is structured and accessed is often interwoven across those modules.
Right.
There have been some efforts to decompose the database along module lines,
Mm-hmm.
essentially trying to give each module, more ownership over its data.
Right. And how feasible are those efforts?
Yeah,
It sounds like a delicate balancing act.
it can be quite challenging in practice.
Okay.
While the idea of each module having its own database sounds clean,
Hmm.
actually implementing and managing that within a single deployment unit
Right.
can introduce new complexities
Yeah.
around data consistency and transactions that span modules.
Okay.
And so it often requires a lot of careful architectural planning and ongoing discipline.
Right. So we've talked about single process monoliths,
Mhm.
modular monoliths,
Mm,
all living within this kind of single deployment.
yeah.
But let's talk about something that sounds a little bit like an oxymoron,
Okay.
which is the distributed monolith.
Right.
So what is that exactly, and why does it tend to get a bad rap?
The distributed monolith is it is a bit of a problematic pattern.
Okay.
So it's a system that's made up of multiple independent services,
Mhm.
but for various reasons, the entire system must be deployed together.
Mm-hmm.
And so you end up with all the operational complexities that you would expect from a distributed system,
Right.
things like network latency,
Mm-hmm.
the possibility of partial failures,
Right.
the challenges of doing distributed transactions.
Yeah.
But you don't get the key advantages that microservices aim to deliver.
Right.
Things like independent deployability,
Mm-hmm.
the ability to scale individual parts of the system as needed.
Right.
So it's often described as like the worst of both worlds.
Right. So you're dealing with the headaches of a distributed setup,
Mm-hmm.
but without the freedom that it's supposed to provide.
Exactly.
So how does this kind of architecture even come about in the first place?
I think it often stems from a lack of clear thinking
Okay.
about how to divide the system into truly independent components. If you don't have strong boundaries between your services,
Yeah.
and they're very tightly coupled, meaning a change in one requires changes in many others,
Yeah.
you lose that independent deployability.
Right.
And this lack of focus on principles like information hiding,
Right.
where each service should really only expose a well-defined interface and hide its internal workings, can really lead to this situation.
Interesting.
I think in my experience, seeing a distributed monolith in action is a strong motivator to really understand how to do microservices well.
That makes a lot of sense. You're getting all the complexity of distributed systems
Mhm.
with the inflexibility of a monolith.
Absolutely.
Okay, so let's talk about something called delivery contention.
Okay.
How does this concept relate to monolithic architectures?
So delivery contention arises when you have a large number of developers or teams working on a single shared code base.
Okay.
And this can manifest in several ways.
Okay.
Conflicts when multiple people need to modify the same parts of the code. Difficulty in coordinating when different teams want to release their changes.
Right.
And just general lack of clarity around who owns which parts of the system.
Yeah.
And who gets to make decisions about them.
Okay.
So think of it like trying to edit the same document simultaneously
Right.
with a huge team.
Yeah.
Lots of potential for conflicts and slowing everyone down.
Yeah. So
Yeah.
as more engineers are contributing to this one big code base,
Mm-hmm.
it just becomes increasingly difficult
Yep.
to manage and coordinate those changes effectively.
Exactly. And while having a monolithic architecture doesn't automatically mean you're going to have delivery contention,
Sure.
the shared nature of the code base can definitely amplify these problems as your team grows.
Right.
Microservices, by having more clearly defined boundaries between services, can offer more explicit ownership and more flexibility
Right.
in managing independent deployments, which can help reduce delivery contention.
Okay.
But it's also important to remember that even with microservices,
You can still run into coordination issues if dependencies aren't managed properly.
right, it's not a guaranteed fix.
Right.
Okay, so, despite some of these potential pitfalls, you highlighted some really significant advantages of sticking with either, a single process or well-structured modular monolith. So what are some of the key benefits that you think make these still relevant architectural choices today?
Yeah. So I think one of the most compelling advantages is the simpler deployment picture.
Mm-hmm.
You're dealing with deploying one thing,
Yeah,
or maybe a few identical copies,
right.
rather than potentially this complex web of interconnected services.
Right.
This simplicity inherently avoids many of the failure scenarios and operational overhead
Yeah.
associated with distributed systems.
Mm-hmm.
And so this ease of deployment also extends to the developer experience.
Okay.
So it makes local development, debugging, and end-to-end testing much more straightforward.
You don't need to spin up and manage a whole ecosystem of dependent services just to test a small change.
Right. That ease of local development and testing is a huge plus,
Absolutely.
especially when you're trying to, onboard new team members
Totally.
or, quickly iterate on features.
Yeah.
So what other benefits do you see with, this more monolithic approach?
So code reuse within a monolith is generally much simpler.
Okay.
If you need to use a piece of functionality in another part of the application, it's usually just a matter of calling a function or accessing a class within the same code base.
Right.
In a distributed system, you have to make more complex decisions about whether to duplicate code, create shared libraries, or expose the functionality as a separate service with its own API and potential network overhead.
Right.
So that directness of code reuse in a monolith can be quite appealing.
Yeah.
And can lead to faster initial development.
Right. So simpler deployment, easier developer workflows,
Yeah.
straightforward code reuse. Sounds like there's a strong argument to be made here.
Absolutely.
Especially in certain situations.
I think it's a shame that the term monolith has often become loaded with negative connotations.
Right.
A monolithic architecture is a valid and often a very sensible default choice, especially when you're starting a new project or when your team size and complexity are still relatively low.
Right.
I would argue that you should probably start with a monolith, unless you have very clear and compelling reasons to go down the microservices route from day one. The burden of proof should be on why you need microservices.
Right.
Not why you should avoid a monolith.
That's a really good point.
Yeah.
It's about, making a conscious decision based on, the specific context and needs of your project.
Absolutely.
Rather than just chasing the latest architectural trends.
For sure. And I think for those of you who are preparing for senior level technical interviews, being able to articulate this nuanced understanding that you recognize the validity and the different flavors of monolithic architectures will really demonstrate a mature perspective on software design. It shows that you can think critically about trade-offs instead of just reciting,
Together, what would you say are like the key takeaways?
Okay.
For those of us who are preparing for these more advanced technical discussions.
So I think the crucial thing to remember is that monolith isn't a single entity.
Right.
We've walked through the distinctions between single process modular and the often problematic distributed monolith.
Right.
Each has its own set of characteristics, advantages, and disadvantages. Understanding these nuances is fundamental to having, informed conversations about architectural choices.
Yeah.
Be ready to discuss scenarios where a monolith might be a perfectly reasonable, even optimal solution.
Right.
And articulate the trade-offs when comparing it to more distributed approaches.
Excellent. And on that note, here's a question for you to ponder.
Okay.
When you're evaluating different ways to build software, whether it's a monolith or something more distributed.
Yeah.
What do you think are like the absolute most critical factors to consider beyond just the architectural pattern itself? Think about the specific business goals, the size and skills of your team, the expected scale and complexity of the system, and the real-world operational implications of each choice.
For sure.
So that's all for this deep dive. Thanks for joining us.
Thanks for having me.
It's been a pleasure.
Yeah, it's been fun.
Yeah. All right. We'll see you next time.
See ya. Bye. Bye.